So here is question number 16. The ratio of masses and radii of two planets are 2:3 and 8:27. The ratio of respective escape speed from their surfaces will be what? Now, the question belongs to gravitation, and we know the expression for escape speed, that is under root twice gm divided by r, where m is the mass of planet and capital R is the radius of the planet. Now, there are two planets, their masses ratio and their radii ratio are given, so we can write m1 is to m2 as 2:3 or 2/3, and r1 upon r2 is 8/27. Using the expression for escape speed, we can write the escape speed for the individual planets. The escape speed for planet 1 VE1 equals under root 2gm1 divided by r1. On the other hand, the escape speed for the second planet, that is VE2, given by 2gm2 upon r2. Now taking the ratios, we will get VE1 is to VE2 equals under root 2gm1 upon r1 multiplied by under root r2 upon 2gm2. 2g will be cancelled out. Ultimately, we will get VE1 upon VE2 as under root m1 upon m2 multiplied by r2 upon r1. Now putting the values of m1 and m2 and r2 ratio r1, we will get m1 by m2, that is 2:3, r2 by r1 will be 27:8. Cancel by 4 times, 9 times. Ultimately, we will get the ratio of their escape speed as 3:2. So we will proceed with option number 3. Option number 3 will be absolutely correct. Now let us proceed with the next question, question number 17. A system consists of two concentric spherical shells of radii small a and small b, given that b is greater than that of a, maintained at a temperature T1 and T2 respectively. The radial rate of flow of heat through the substance between two concentric spherical shells is proportional to. Now, since we know that according to law of heat conduction or thermal conduction, you can say, radial heat flow between two concentric shells will be given by rate of flow of heat is equal to 4 pi small a small b k change in temperature divided by delta x, which is given by 4 pi a b k T2 minus T1 divided by b minus a. Now we have to find out that the heat or rate of flow of heat is proportional to 4 pi is a constant, k is a constant, temperature they are kept at particular temperature T2 and T1. So these things are constant. It means this flow of heat is actually proportional to their geometry, that is AB divided by B minus A. So now we will proceed with the second option is the correct option. Now let us see question number 18. Figure shows the trajectories of three different bodies projected from level ground. Select the incorrect option. Let us read the options one by one. First of all, the time of light is same in all the three cases. Y component of initial velocity is same in all the three cases. Velocity at highest point of trajectory is same in all the three cases. And the maximum height attained by the particle is same in the all three cases. So if we see, we will find that H max is same in all three cases. So we can say that H max, that is u square sine square theta by g, 2g, is what? Constant. It means u sine theta. U sine theta must also be constant, and if you think, you will find that u sine theta is the initial vertical velocity. It is the vertical component of initial velocity. So vertical component of initial velocity is constant. Y component of initial velocity is constant. So second option is correct. We have to choose the incorrect option. Now we know that the time of flight is also given by 2u sine theta divided by g. If u sine theta is constant, then whole factor will be constant. It means the time of flight is also same. So option number 1 is also correct. But we have to pick the incorrect option. Option number 4. The maximum height attained by the particle is same in all the three cases. This is also true. We already have seen in the diagram. Now let us focus on option number 3. Velocity at highest point of trajectory is same in all the three cases. We know that at highest point the particle has only horizontal component of speed, and if they have different range, then their horizontal component will also be different. It means if their horizontal component is different, so third option cannot possible. It is incorrect for this situation. Okay, now we will proceed to the next question, question number 19. In question number 19, it is saying that a particle of mass 1 kg is moved under the action of a force, and velocity time graph of the particle is given in the diagram. Work done by the force from t equal to 0 to t equal to 6 we need to find out. If you see the graph, you will find that the initial speed is 0, the final speed is also 0. It means there is no change in kinetic energy. According to work energy theorem, we know that work done is equal to change in kinetic energy, which is 0 here. Therefore, work done is also 0. Therefore, so we will proceed with option number 4. Now let us proceed to the next question, question number 20. In the figure shown, the tension in the string are T1 and T2 for figure 1 and 2 respectively, and the acceleration of mass m are A1 and A2 for figure 1 and 2 respectively. Select the correct option. Now we have two situations. One is named as figure 1 and other is in figure 2. In figure 1, an external force of 2 mg is acting. So, see the situation in figure 1. Consider this point of the string. As string is massless, it means downward force will be equal to upward force. So, for figure 1, we got the value of tension T1 as 2 mg. So, here will also be tension 2 mg. One downward force, that is weight, is acting. The net force will be what? T1 minus mg. That is 2 mg minus mg, which gives you mg is equal to mass into acceleration. T1 minus mg equals mass into acceleration. You will get the value of acceleration here. That is g. This is A1. This is A1. Now consider the situation in diagram 2. In diagram 2, the tension is T2. In such kind of situation, tension T2 or tension in the string will be given by the expression 2m1 m2 divided by m1 plus m2 multiplied by gravity g. After solving, we get the value of T2 as 4 mg divided by 3, and the acceleration we will get from here, that is A2, will be g by 3. Now read the options and compare them according to your situation and pick up the correct answer. So here T1 is 2 mg, T2 is 4 mg by 3. T1 is greater than T2. This is clear. And acceleration of situation 1 is g. On the other hand, acceleration in situation 2 is g by 3. So A1 is greater than A2. T1 is greater than T2. We will go with option number 3. Now let us proceed to the next question.